In the recently revealed fourth quarter of 2025 report, Tesla confirmed they have conquered the holy grail of the energy sector, mass-producing 4680 battery cells with 100% dry-coated anodes and cathodes. Have you ever wondered why electric cars remain more expensive than gas cars despite a decade of development? The answer lies in the archaic battery cooking stage, the traditional process. Wet coating requires mixing materials into toxic chemical solvents, then running them through massive drying ovens, longer than a football field, just to dry that layer of slurry. Tesla has officially executed these ovens. Imagine a battery factory that operates as fast and compactly as a Coca-Cola bottling line. That is exactly the vision the dry cathode has just turned into reality. This process reduces factory footprint by up to 70% and slashes capital expenditure by nearly 40%. Previously, experts like Robin Zeng of Cathode claimed dry cathodes were impossible because the cathode materials are extremely hard and sharp. They would crush Tesla's powder rollers in an instant. But now, Tesla has confirmed the sustainable operation of this line in Austin, Texas. This is the key to realizing the $25,000 electric car the world has been waiting for. The real difference lies in the technical figures that only those in the industry can fully appreciate. Range anxiety is actually just a consequence of poor heat management. With the old 2170 cells, electricity had to pass through a tiny tab, a conductive lead creating a bottleneck, and generating massive heat during fast charging or high-speed driving. Would you choose a small faucet or a cascading waterfall? The tabless design of the 4680 is that waterfall. By turning the entire edge of the material roll into a conductor, Tesla has shortened the electrical travel distance from 250 millimeters to just 15 millimeters. This not only reduces internal resistance to a record low of about 5 to 7 milliohms, but also allows charging speeds to increase by 10% to 20% while the battery stays cool. More importantly, the energy density of these dry cells is heading towards the 300 to 330 watt-hours per kilogram mark, far exceeding the approximately 260 watt-hours per kilogram of old technology, helping cars go further without increasing the size of the battery pack. Why is Tesla quietly slipping this battery into the Model Y long range in the United States right now, instead of other high-end models? This is a brilliant political and economic move by Elon Musk. How do you sell cars cheaply, receive government subsidies, and remain immune to global trade wars all at once? By self-producing 4680 batteries in Texas, with the dry process, Tesla achieves a perfect tariff shield. They secure the full $7,500 support from the United States government due to 100% domestic origin, while no longer depending on cell supplies from Chinese rivals who are being surrounded by tariff barriers. Furthermore, the 4680 battery is designed as a structural battery pack, turning the battery into the car's floor. This structure eliminates about 10% of excess weight, equivalent to a nearly 50 kilogram reduction compared to the Model 3, helping the Model Y become lighter, stiffer, and achieve optimal performance that no other automaker can currently replicate. While competitors like BMW are trying to mimic the 4680 cylindrical format, they still rely on old, expensive wet drying processes through suppliers like AESC. Tesla is a decade ahead in manufacturing philosophy. They are no longer just a car company. They are a high-speed chemical production entity with the ability to print batteries like a newspaper. The success of the dry cathode also paves the way for the elimination of toxic NMP solvents, making the production process more environmentally friendly than ever, meeting the strictest green standards of 2026. If the 4680 were truly a failure, as rumored, Tesla would not have confidently cut production of the Model S and X to pour all resources into the 4680-powered Model Y and Model 3. This is a defiant declaration. The era of cheap high-performance and fully localized battery production has officially begun, marking the end of the dominance of obsolete technologies. To understand why the $60 per kilowatt-hour figure is making rivals like Toyota, Volkswagen, or even BYD restless, we need to look at the core cost structure of a battery cell. In the current electric vehicle industry, the average price per kilowatt-hour still fluctuates around the $100 to $120 mark. Tesla approaching the $60 mark is not just a price cut. It is a thermal shock hitting the profits of both the traditional gas car and the conventional electric vehicle industries. Did you know that in a typical electric vehicle battery, you aren't just paying for lithium or nickel, but you are paying for the electricity bill of those massive drying ovens. The key point lies in the elimination of the wet coating process. In the old process, NMP solvent accounted for about 15 to 20% of operating costs just for recovery and toxic exhaust treatment. When Tesla switched to dry electrodes, they completely cut out the hundreds of meters-long oven systems and the expensive solvent recovery towers. From a technical perspective, this reduces the factory's energy consumption by up to 10 times. If a typical battery plant consumes megawatts of electricity just to dry solvents, Tesla's 4680 plant in Texas operates like a high-speed printing line with extremely low energy consumption. This is the factor that helps Tesla save about $15 to $20 per kilowatt-hour from the factory operation alone. Why can't competitors do the same, even if they know the formula? The answer lies in the secret of the rollers. Another financial barrier Tesla has broken is capital expenditure. To build a traditional battery plant with a 10 gigawatt-hour capacity, you need about $1 billion. With the dry process, because the factory area is reduced by 70%, Tesla only needs to invest about $600 million for the same capacity. As the equipment depreciation cost per battery cell drops, the production price will fall vertically. Data analysis shows that the combination of the tabless design reducing expensive copper and aluminum used for leads and the dry process helps Tesla save an additional $10 per kilowatt-hour in raw materials and auxiliary components. Compared to Chinese rivals dominating the low-cost lithium iron phosphate segment, Tesla now holds an overwhelming advantage: energy density. Lithium iron phosphate batteries, though cheap about $70 to $80 per kilowatt-hour, are heavy and weak. Meanwhile, Tesla's 4680 battery is a nickel-rich chemical system with high performance, but the production cost is now equivalent to or even lower than lithium iron phosphate, thanks to the dry process. This is the true checkmate. Tesla isn't just making cheaper batteries, they are making the best batteries at the cheapest price. When the cost hits the $60 per kilowatt-hour mark, a 75 kilowatt-hour battery pack for a Model Y will only cost Tesla about $4,500 compared to the $8,000 to $9,000 range of its competitors. This $4,000 gap is the war chest that allows Tesla to trigger price wars at any time while still maintaining extremely high profit margins. Tesla has officially turned the battery from the most expensive component into its greatest competitive advantage. The solution to the dry cathode challenge on the 4680 battery cell marks the end of the era of expensive and dependent electric vehicles.